Hello and welcome. In this video we're going to be talking about the concept of expected frequency. And to do that, what we need to sort of understand is the difference between theoretical probability and what relative frequency is. Now, it is worth noting that relative frequency and expected frequency are not the same thing, okay? And I'm going to get to that a little bit later when we sort of talk about it, okay? When we've been in class, we've talked about relative frequency as being the whole idea of experimental probability. That is probability that's determined by an experiment. Okay, and you might notice that our relative frequency is a little bit different to our theoretical probability. Okay, so when we talk about theoretical probability, it's the number of outcomes that we would expect. Okay, so for example, for every 6 rolls, I'd expect to roll a 1 at least once. Okay, because we have a 1 in 6 chance of that happening when we roll a 6-sided die. That's a theoretical probability. In actuality, it doesn't always turn out that way with relative frequency, okay? So another example would be thinking about tossing a coin. We would expect, if the coin was unbiased, to come out heads and tails 50% of the time each, but in actuality, again, that doesn't happen. So what you need to understand is that theoretical probability and experimental probability, or relative frequency, are slightly different from each other, okay? That brings us to what we're actually here to talk about today, and that's expected frequency, okay? So the expected frequency is the number of times that we would expect an outcome to happen, okay? It's not the same as relative frequency when we talk about this, okay? So the number of times that we would expect an outcome to happen. So the way that we calculate it is we calculate the number of trials and we multiply the probability that it's going to happen, okay? So that's just shortened down to NP. So for instance, if we roll the dice, a dice 60 times, just a normal 6-sided die, we would expect to roll a 1/6 of those times, okay? So what we're doing is we're just taking the number of trials that we have and we're multiplying by the probability, okay? So this is 1 over 6 times 60. So we would expect, okay, and this is what I mean when I say expected frequency, all right, we would expect to roll a 1 10 times, okay? So when I say expected frequency, that's how many times we would expect an outcome to occur. Not how many times it has in an experiment, but what we would expect. And when I talk about relative frequency, we talk about the probability of an outcome occurring relative to the rest of the experiment, which is why we call it the relative frequency, okay? Now, one thing that's worth noting is that the more times you perform an experiment, so the more times you flip a coin, the more times you roll that dice, the closer the experimental results will become to the expected frequency. So what we'd expect as the theoretical probability. Okay? So eventually your results will begin to approach those values. Okay? Providing that the coin or the dice or whatever it is you're doing is not biased. Okay? So let's have a little bit of a look at an example question. So this is a HSE question that I've taken and I've just sort of reworded just so we could have a little bit of an example of it in relation to everything that's going on. Okay, so first things first, we're given a table, right? The number on the dice are the outcomes, right? And the frequency that has occurred. Straight away, the first question asks us to calculate the relative frequency of rolling a 1 on a 6-sided die. To do that, we need to know the total number of experiments that we've had. Okay? So what we do is we just add up how many times we've rolled the dice, okay, all the way through here. Once you've done that, you'll realise you have a total of 72 times. Now, that was if we hadn't been given the fact that it was rolled 72 times in there. You could just add through the table, okay? It is given to you in the question, okay, but just understand that we can work down the table here. All right, so when I talk about the relative frequency of rolling a 1, well, the relative frequency, and this is just how I write it, so a rel freq of 1 is equal to, well, it's 6 times out of a total of 72 times. Okay, so that's a probability using our experimental data, the relative frequency, of rolling a 1, given what's happened in this experiment. Simplifying that down, we end up with a 1 in 12 chance. Okay? When I talk about the expected frequency of rolling a 1, however, okay, which is how many times we would expect, not how many times we did, all right, we take the number of trials that we've done, okay, and we multiply by the probability, this whole formula up here. So the expected frequency, okay, is equal to the number of trials, 72, multiplied by the probability that the outcome will occur. Well, it's a six-sided die, so we'd expect it to occur 1/6 of the time. Okay? When we simplify that down, we would expect the total to be 12 times. Okay? That's the expected frequency of rolling a 1 here. Notice that we haven't got that. It's only been rolled 6 times. Okay? So let's have a look at a couple of more questions now, right? So when we talk about the relative frequency of rolling a 3 or more, so that's all of these outcomes, okay? We're going to calculate them all. We just add them all together and divide by how many trials we have. So relative frequency of greater than or equal to 3, okay, just so you can see what I'm doing. Okay, the relative frequency of greater than or equal to 3, we just add all of them up, and you'll notice we have 54 out of 72 outcomes, which will simplify down to 3/4, okay? And how many times would we be expecting for that to happen? Well, the easiest way for us to think about is how many outcomes do we have out of the total 6, all right? So we would expect a probability of 4 of the total 6 outcomes, okay? So for the expected frequency, all right, I'm just going to shorten this down so you can see what I'm doing. All right, we would expect 4 out of 6 multiplied by 72, okay, which would give us 48 times. That's what we would expect, which isn't too far from what we've actually achieved. 48 times is what we expect. We would roll all of these outcomes together, and we rolled them 54 out of the possible 72 times, okay? So the final question, which is what actually comes from the HSC question initially, is it says, using the table above, which number on the die was obtained the expected number of times? Okay, well, we can do the expected number of times, right? Because they're all equally likely outcomes. We would expect all of them to be rolled 1/6 of the time. Now, we've already done this calculation above, but I'll show you again. All of them we would expect to roll 1/6 of the time. Well, 1/6 of 72, when we multiply all this out, will give us 12. So what we do is we look down our frequency column until we spot the number 12, okay? So you'll notice that 2 is the only number that's been rolled the expected number of times, right? So we say, therefore, 2 has been, rather than is, has been rolled the expected number of times. Expected number of times, okay? So that's how we work with expected frequency, all right? And just make sure that you understand the link between experimental probability or relative frequency and theoretical probability, okay? How they're not quite the same, all right? But we can use them to work with each other, okay? So that's all that I have for you today. Thank you very much.